Now in this class, I am going to discuss about law of conservation of energy. So question will state and prove law of conservation of energy in case of freely falling body. So states that in a closed system, the total energy of a body remains constant. In this closed system, the total energy of a body remains constant. So statement, in a closed system, the total energy of a system remains constant. So consider this as, consider it is a body of mass m, and falling freely to earth surface, at point A. H is a height. So now at point A, at a point A, the body falling freely to the earth's surface, so potential energy PE equals mgh, where m is a mass, g is a acceleration, h acceleration due to gravity, h is a height. So at the point A, kinetic energy 0. So Ke equals 0. The total energy at A is, the total energy at A equals PE, potential energy, plus kinetic energy. So total energy E equals potential energy mgh plus the kinetic energy 0. So E equals mgh. Consider it is equation 1. At a point A, the total energy mgh. So consider this is equation 1. Now at point B, at point B, let the distance traveled by a body be x. At the point B, the distance traveled by a body be x. So distance traveled be x. At this point B, the potential energy PE equals mg into h minus x. At point B, the potential energy mg into minus h minus x. The kinetic energy of mvb square. At point B, the kinetic energy of mvb square For now, for the motion from A to B, from the motion A to B will be the linear equation V square equals U square plus 2AS. So the linear equation V square equals U square plus 2AS. So where U is the initial velocity, V is the final velocity, A is the acceleration, S is the displacement. From the motion from A to B, from a point A to B, the initial velocity of body U equals 0. The initial velocity of the body U equals 0. U equals 0. The final velocity VB from A to B, the final velocity VB. So V equals VB. A is the acceleration. From A to B, the acceleration due to gravity. So A equals G. S is a displacement. So displacement from A to B is distance x. So S equals x. So V equals VB square. VB square equals U0 plus 2A equals G. S equals x. So VB equals 2GX. 2GX. So the kinetic energy of mVB square. So kinetic energy of mVB square. So of m into VB 2GX. 2GX for kinetic energy of mVB square. VB consider 2GX. So this 2 and 2 will get cancels. So remaining kinetic energy KE equals m into GX. mgx. Kinetic energy equals mgx. Now the total energy at point B. The total energy at point B equals potential energy plus kinetic energy. At point B, the potential energy mg into h minus x. The kinetic energy mgx. So total energy E equals potential energy mg into h minus x. mg into h minus x. plus the kinetic energy mgx. So E equals mg into h. mgh minus mg into x. So mgx plus mgx. So E equals mgh this minus mgx plus mgx get cancels. So remaining E equals mgh, where E is a total energy, m is a mass, g is a acceleration due to gravity, h is a height. Consider it is equation 2. Now I will write at point A, total energy E equals mgh as equation 1. So I am writing once again the total at a point A, total energy E equals mgh equation 1. This is equation 2. E equals mgh equation 2. So now at point C, at a point C, at a point C, when the body reaches to earth, when at a point C, when a body reaches to earth, height becomes 0. So height h equals 0. Potential energy P equals 0. At the point C, potential energy and height becomes 0. The kinetic energy Ke of mv square c. So Vc square. At the point C, kinetic energy of mvc square. So now for this motion from A to C. Now for the motion from A to C, the linear equation v square equals u square plus 2as. For this point from A to C, the initial velocity u equals 0. The final velocity v equals vc displacement S equals from A to C is H. The displacement S equals A to C is H. So, for the linear equation, V square equals Vc square equals initial velocity u equals 0 plus 2 a equals g, s equals h. So Vc square equals initial velocity 0 plus 2gh. We can written as Vc square equals 2gh. So the kinetic energy is of mvc square. For point C, the kinetic energy of mvc square. So vc square equals 2gh. So Ke equals of m into Vc square 2gh. 2 get cancels. So remaining kinetic energy Ke equals m into gh, mgh. The total energy of a point C is potential energy plus kinetic energy. So total energy E equals, at the point C, the potential energy is 0. At a point C, the potential energy is 0. Plus, at point C, the kinetic energy Ke equals mgh. Now, the total energy E equals mgh. Consider it is a equation 3. So now from the equation 1, equation 2 and equation 3. So from equation 1, E equals mgh. Equation 2, E equals mgh. Equation 3, E equals mgh. So 3 equations, same thing. The total energy E equals mgh. So total energy E equals mass m, acceleration due to gravity g, h, height h. So this shows that from equation 1 and 2 shows that the total energy of a closed system remains constant. From equation 1 and 2, 3, we know that it shows that the total energy of a closed system remains constant. This shows that the law of conservation of energy at a closed system, the total energy remains constant.